Hello guys and welcome to this tutorial. Today we will be learning about a common web applications vulnerability titled cross-site scripting. We'll dive into the details of the three types of cross-site scripting, more specifically reflected, stored, and DOM-based. We'll combine theory with practice by performing our own attacks, and during that process we'll use tools such as Burp Intruder to automate customized attacks and DOM Invader to facilitate the process of finding DOM-based vulnerabilities. So with that said, let's get down to work. Alright guys, let's start by talking about reflected cross-site scripting. What is reflected cross-site scripting? Well, one of its signatures is if a website takes data from an HTTP request and displays the data, or in other words, reflects the data back to the user without performing any kind of filtering or sanitization, then it is most likely vulnerable to reflected cross-site scripting. To further clarify, let's take an example. In the first step, the hacker has to deliver the payload to the user, which in this case is a crafted URL containing the malicious JavaScript code. So have a look at the URL. As you probably already know, any word after the question mark in a URL is considered to be a parameter which holds a value. So in this URL, we can see that it contains embedded JavaScript code as a parameter. So that means that the malicious URL is ready to go, but it is completely useless unless the user clicks on it. So how can the hacker deliver the payload to the user? Well, there are various delivery mechanisms such as phishing attacks, forged mail, which invites the user to click on a link. And there are also other forms of social engineering techniques that can be employed. But for this case, let's assume that the hacker managed to deliver the URL to the user. In step 2, the user will click on the URL, which will then trigger a request to the server. The response from the server in step 3 will now contain the malicious JavaScript code that was crafted by the hacker. After that, the user's browser will receive the malicious JavaScript code and will unfortunately execute it. So as a result, in step 5, the user's browser will send the data belonging to the user back to the hacker. It could be data such as cookies, session token, and so on and so forth. Now in step 6, the hacker most probably has enough data to enable him to hijack the user's session and thereby enabling the hacker to pretty much do whatever the user is able to do in an application. For instance, the hacker will be able to view any information that the user is able to view, perform any action within the application that the user can perform, modify data, and so on and so forth. So now it's time for us to apply what we have learned by performing our own reflected cross-site scripting attack. So one of the best resources for web security training is Portswigger, which is the company that has developed Burp Suite, which is one of the most popular pen testing tools around. So what they offer is a lot of free learning materials and labs that you can use to combine theory with practice. So let's have a look at what Portswigger offers. So as you can see, I have already navigated to the cross-site scripting section or page. And we can see here that we have quite a detailed description of what cross-site scripting is in general, how it works, proof of concept, in other words, how we can find it, and so on and so forth. In this case, we are only interested in the reflected cross-site scripting. So let's click on that. Click again here. And now we are in the reflected cross-site scripting page with a description, and we are interested in the lab. So the objective of this lab is to exploit a reflected cross-site scripting vulnerability that exists in the search functionality. And in order to solve this lab, we need to perform a cross-site scripting attack that calls the alert function. So in other words, we want to display a dialog using the alert function. So let's access the lab and see what we can do. So this is the vulnerable page, which is a blog in this case, we have some blog posts here which we are not interested in at all. So let's go here. And as you remember, in the description they said that the vulnerability exists in the search functionality, and that we should call the alert function in order to succeed with our objective. So let's type the following then. We create a script, alert, and then we type whatever message we would like. Of course, you can type whatever you want there. And let's close the script tag. So let's see what happens if we click the search button. Aha! Now we have the dialog up here. It has popped up and it is saying XSS is fun. So that means that we have succeeded with our objective. So let's click on OK. So now we know that we have successfully exploited the reflected cross-site scripting vulnerability. But what actually happened in the background? As we clicked on the search button, a request containing the malicious code was sent to the server. Next, the server received the request and then embedded the malicious code into the HTML response page. This page is later on displayed to the user. We can confirm that the malicious code now resides in the HTML page by launching DevTools. So let's select the inspector and inspect the heading that displays the search value. And if we expand the heading, here we can see that the malicious code was indeed successfully injected into the HTML page. Alright guys, let's move on by talking about stored cross-site scripting. Stored cross-site scripting occurs when an application allows users to store data in the application, which is then displayed to other users without being properly filtered or sanitized. So to further clarify this concept, let's take an example. Let's assume that the target is a blog site that, among other things, allows users to submit comments on the blog posts. So now our favorite hacker gets down to work. For some reason, a blog post named "A Guide to Online Dating" triggered the hacker, and therefore he decided to target it. So in the first step, the hacker navigates to the comments section in the blog post and submits a comment containing the malicious code. What happens next is that the server receives and stores the malicious code in the database. Moving on, in step 2, we can see that the user visits the targeted blog post. The server then receives the request and responds with the requested web page, which now also contains the hacker's malicious code. Next, the user's browser will receive and execute the malicious code. Consequently, in step 5, the browser will send the user data to the hacker, and that can be data such as cookies, session tokens, and so on and so forth. Now, after receiving all the data, the hacker is now able to hijack the user's session. Alright guys, now we know more about the theory, so let's move on and perform our own stored cross-site scripting attack. So now we have navigated to the stored cross-site scripting lab, and as we can see, we have various kinds of blog posts. So let's just select one of them. Let's say that we would like to target the one about shopping. So let's view the post. Here we can see the blog post. We can see that some users have left comments. And then we see that we also have the option of leaving our own comment, which is great. So now we would like to know, is this comments field vulnerable? So in order to investigate that, we could input the proof of concept script that you have seen before. Script alert. XSS is awesome. Script. We close the script. And before posting it, we need to add some additional information, name, email, and a website. So now if everything goes as we want, we will be able to see an alert containing the message XSS is awesome. Then we know that the browser actually executed our payload. So let's see what happens. Let's post a comment. We have some indication that we have solved the lab, but no pop-up here. So let's go back to the blog. Now we can see that we have an alert containing the message XSS is awesome. And this of course indicates that our payload was executed by the browser, which is great news for us, but bad news for the application owner. So who does this actually impact? Well, anyone that will visit this particular blog post, which is the shopping blog post, will be targeted. So just for clarity, let's go back to the page here, the main page. Let's navigate as a user to the shopping post. Let's view the post. And as you can see here, it immediately popped up. This means that any user who views this particular blog post will be affected. So this attack is quite effective. And the main reason for that is due to the fact that the payload is actually stored in the database and that it is retrieved every time a user views a blog post. So let's move on and talk about the third type of cross-site scripting. Now, to be honest, guys, this one is a little bit more tricky. So before diving into the details, let's recap. By now we have established that both stored and reflected cross-site scripting share a specific pattern where the malicious payload is sent to the server and then the server embeds the payload into the HTML response page that is then displayed to the user. Now this means that any kind of server-side protection such as a web application firewall will most probably detect the payload and prevent the attack. So now the question is there a way for our hacker to avoid sending the payload to the server in the first place in order to evade server-side protection? Well, in fact there is, and that leads us to the third type of cross-site scripting, namely DOM-based cross-site scripting. So this vulnerability occurs if the application writes data to the DOM without performing proper sanitization. Let's have a look at an example. So here we have a simple HTML page that is customized based on the username. When looking at line number 6, we can see that the name is fetched from the URL. And then we use document.write to write the name on the page. Now keep this line in mind. We will have a look at it later on. So what happens if the hacker injects a malicious script into the URL? Well, to find out, let's take an example. In the first step, the hacker delivers a URL containing the malicious payload. After that, the user clicks on the link, which triggers an HTTP request that is sent to the server. But here we have a very important detail. The browser treats anything after the hash sign as a fragment, which means that anything beyond the hash sign will not be sent to the server. Now, with that in mind, our hacker has intentionally placed the payload after the hash sign in order to evade any kind of security mechanisms on the server side. In the next step, the server responds with a static HTML page. And please note, this response does not contain the malicious payload. So now the browser has received the response, but as you probably know, browsers do not understand HTML. So instead, the browser starts to build the DOM of the page by simply parsing the HTML into the DOM. And in that process, the URL property in the DOM is populated with the URL of the current page, which of course contains the malicious payload. Now eventually, the parser will reach the script section and execute it. Now as a result, the raw HTML of the page will now be updated and will contain the malicious payload. In the next step, the browser will locate the payload and execute it. And after that, the browser sends the user's info to the hacker. Now finally, the hacker is now able to hijack the user session and do anything that the user is able to do. Alright guys, to further clarify, let's take an example. Now for this example, I have launched a vulnerable application called DVWA, which stands for Damn Vulnerable Web Application. And as we can see, we have different types of vulnerabilities that we can play around with, but for now we're only interested in DOM-based cross-site scripting. So let's click on that. So what are we seeing here? Well, we have a very basic page where the only thing we can do is to select a language. So in fact, there is nothing more than that. So now the question is, how do we find and exploit DOM-based cross-site scripting vulnerabilities? Well, we have two things that we need to find. The first thing is a source that we can control in order for us to inject our payload. In fact, the most common source for DOM XSS is the URL. So let's keep that in mind. The second thing that we need to find is a sink, which enables our payload to be executed. Alright, so how do we go about and find these two things? Well, we can try to peek under the hood by launching DevTools. And our goal is to try to find a script that we can tamper with in some way. And before that, actually, let's click on English here, selecting the English language. Let's proceed by expanding these sections here. And here we go. We have a script. And in fact, in the first glance, we can see that there is something interesting going on. We can see that we are using the document.location.href, which basically returns the full URL of the current page. And why is this interesting, you might ask? Well, as I mentioned earlier, the most common source for DOM XSS is in fact the URL. So far so good. After that, we have a variable lang, which stands for language. This variable has a value that consists of a subsection of the URL. So in this particular case, lang equals English. All right. And after that, we are calling the document.write function. And what it does, it manipulates the HTML by adding an option to the page containing the value of the lang variable. So here we can see that we are referring, in this option, we are referring to the lang variable. So let's have a quick look and see if this in fact can be an opportunity for us. So let's go to the XSS wiki, and just to give you an understanding, here we can navigate to sinks. And as I mentioned, this function, what it does, it basically manipulates the HTML. So it's reasonable to click on HTML manipulation sinks. And here we can immediately see that in fact the document.write function is a potential sink, which is great news for us, of course. So let's try to summarize. What is interesting here is that we see that user-controlled data is flowing from the source, which in this case is the URL, and ends up in a sink, which is the document.write function. And that will ultimately enable our payload to be executed. So to prove our theory, let's perform an attack. Just to show you what is going on in the background, let's navigate to the Networks tab and click on Select. Open up the HTTP request, and here we can clearly see that the request that is going to the server in fact includes the default parameter. So we could potentially try to inject a payload here, but for instance, if there is a web application firewall or other security mechanisms on the server, then the attack will most probably be detected and then prevented. So for that reason, we want to avoid sending the payload to the server. So what can we do? Instead, we can inject the payload as a fragment. And as I mentioned earlier, browsers do not send fragments to the server. So let's see what we can do here. We can add a fragment, hash sign, we add the script, and then we close the script. Now in theory, what should happen now is that this script will not be sent to the server, since it is a fragment. So let's clear this one up and see what happens. pressing enter. There we go. We can already see that our payload has been executed. We are getting the test pop-up, which is the text that I defined here, as we can see. And if we have a look on the HTTP request, we can clearly see that the fragment is not sent to the server. The last thing that we are sending is the parameter English. So this whole section is not sent to the server. So by now we have learned how to find and exploit DOM XSS manually. Now this was a very basic page, but imagine if we were dealing with a real application with a large code base. This would require us to go through many lines of JavaScript code, and that process can be very tedious and time consuming. So now the question is there a more efficient way to find DOM XSS? Well, in fact there is, and that is the DOM Invader, which is a part of Burp Suite. Alright guys, so let's move on and have a brief introduction to DOM Invader, which is a very useful tool that can help you save a lot of time when searching for DOM-based cross-site scripting. So what exactly is DOM Invader? Well, it is an extension that is available in the browser that is embedded in Burp Suite. What it does, it finds DOM-based cross-site scripting by using so-called canaries, which are random alphanumeric strings. These canaries are then inserted into the source. And then next, the DOM Invader will keep track of the canary. If it hits a sink, then it will be reported as a potential vulnerability in DevTools. So to clarify, let's take an example. Now as you can see, I have already launched Burp Suite. We need to navigate to proxy. And we want to launch the embedded browser in Burp Suite. We do that by clicking on Open Browser. And here we go, we can see that it is launched. Let's navigate to the vulnerable application, log in. And then we navigate to DOM-based cross-site scripting. I see that the security level is impossible. Let's just change that really quick before we start. There we go. Now it's correct. So the first step that we need to do is to enable the Burp Suite extension, and we do that by clicking on Extensions and then on Burp Suite. And we need to enable Burp Suite by clicking on this one here. And then we need to change the canary to something that we can actually remember. So for simplicity, let's take test 1, 2, 3. And of course we have various other options, but I will not be going through them in this tutorial at least. Good, so now we need to update the canary and reload the page. All right, so now as it says here, we should have a new tab called DOM Invader in DevTools. We should be ready to go. And yes, that is correct, we have DOM Invader here. It doesn't say too much now. We have sources and we have sinks, but we don't have any result. So what can we do now? We can click on select to select English. And here we can see the parameter English. And the step that we need to take now is basically the same one as the one we did when we did the manual exploit. So what we can do here is to add a fragment. And instead of script, as you remember, since now we are not really sure, do we have a vulnerability or not? We need to find that out. So what we can do here is to insert our canary. There you go, test 1, 2, 3, and we press enter and see what happens. There we go. Indeed, now we can see that we have a source, which in this case is the URL, as we can see here. And this canary, in fact, reached the document.write, which is a sink. So now, if we want to have some more information, where is this code actually residing, we can click on the stack trace. And it now tells us that we need to open the console tag. So let's navigate to there. Click on that one here. And there you go. Now we can see the document.write, which is the sink in this particular case. So just like that, we have identified the source. If we go back here, we have identified the source that we can inject our payload and the sink which enables the payload to be executed. As you might have noticed, this approach is much easier and faster than the previous approach where we had done everything manually. We had to go through the code and to dig in order to find the same results. So in the real world, there might be various security mechanisms that are implemented, such as filters and sanitizers. So one specific payload may work on web application A, but might not work on web application B. So what I'm trying to say here, there is no silver bullet in terms of payload that works on all web applications. There is just no such thing. So our job is to find a chink in the armor in the target and try to exploit that. But in order to do so, we need to hit the target with different types of payloads in order to see which one works. Now obviously, doing that manually is extremely inefficient. Instead, we can use a tool such as Burp Intruder that allows us to automate our attacks against the target. So let me show you how that can be done. As you can see, I've already launched Burp Suite. The thing that we need to do next is to click on Target. We need to add the scope, which basically is the URL of the application that we wish to attack. In this specific case, it's DVWA. So let's click on OK. And then we proceed by clicking on Proxy and turning on the intercept. The intercept will catch all the HTTP requests that are made. And that, of course, enables us to tamper with them and try to inject some malicious code. All right. So far so good. And then we click on the open browser, which I have already done. So it would look something like this. I have navigated to the reflected cross-site scripting. And here it's asking us, what is your name? And as you can see, I've already played around a little bit with it, but let's click on Silverhack and click on Submit. Now, as you can see, nothing is really happening here. And the reason for that is because the HTTP request is actually caught by Burp Suite. So nothing will be happening here. So let's click on that. Here you can see that we have caught a GET request where the parameter name is Silverhack, which is good. So now let's see how we can process this HTTP request. We can right click and send it to the intruder. And then we can see that we have something in the intruder. We click on that. And here we can see that we are now able to select the payload position, basically where the payload should be injected. Now, in this particular case, it has already automatically identified some places where the payload can be injected. It's the name and the security and this one here as well. But for now, we're not interested in these two here. The only thing we want to do is to input the payload into the name parameter. So let's go ahead and clear all the injection points and let's add our own, which is this one here. So what this basically means that Silverhack will be exchanged with a payload. Instead, we will have a payload here. All right. So now we have that. Let's proceed to the payloads section. And here you can enter your payloads. We have an empty list now since we are running the community edition. But what we can do, just to give you an understanding, we can enter new ones. So for instance, let's take the standard one, which is script. Alert 1, and we close the script here and we press add. Now of course we don't have all the payloads in our mind, so there are some good resources. One of them is for instance the cross-site scripting cheat sheet, and this is an excellent resource because here we are able to generate various types of payloads. Based on the selection criteria that we see here, we can select tags, events, and browsers. And if we have a look as we click around, we can see that a new payload is being generated based on our selection. But for now, let's stick to the default selection and go back to all tags. And now we can copy the payload to the clipboard and navigate back to Burp Suite. And we paste the payloads here in this list. And now, as you can see, we have a very long list of payloads to experiment with. So what exactly will happen now? Well, for each one of these payloads that you see here, we will be sending one HTTP request. But instead of sending the value silverhack, we will be sending the payload. All right, so far so good. So let's start the attack and see what happens. We click here, and here we get a warning that the attacks will be throttled due to the fact that I'm using the community edition, and that is fine. And there we go. Now the attacks are ongoing. We can see the status of the HTTP request, and 200 means that it succeeded. We can see the length of the response. But let's dig a little bit deeper here. We can see that our request in fact contains the payload. And if we have a look on the response, we can render it, and it doesn't really tell us so much. Did it succeed or not? It doesn't indicate that at all. Instead, we need to take another approach where we right click and then show response in browser. Now something will be copied. What we will do is we will go ahead and paste that into the browser. And there you go. Now we can see that a pop-up did in fact appear, which indicates that we have found and exploited the vulnerability. So that concludes our short introduction into Burp Intruder. Alright guys, so that is going to be it for this video. I hope you have learned something valuable today. If you want to support this channel, you can like, subscribe and turn on the notification bell. And if you have any questions, please let me know in the comments section. So thanks for watching guys, and see you in the next one.